Hello everyone. Welcome to our webinar for the research project Toward Understanding the Real-World Effectiveness of Augmentative and Alternative Communication for Students in School Activity Settings. My name is Tracy Shepard. I'm a speech-language pathologist and work in the Augmentative Communication Service at Thames Valley Children's Centre in London, Ontario, as well as an education coordinator in the centralized equipment pool at the Holland Bloorview Kids Rehabilitation Hospital in Toronto. I'm also a member of the research team for this project that includes Anne-Marie Renzoni, Anna O, and Steve Ryan from Holland Bloorview, Diane Parr from Hamilton Wentworth District School Board, Lisa Nielsen from Toronto District School Board, and Gail Olzos from York Catholic District School Board. Anne-Marie and Steve will be presenting the findings from our research study a little bit later in the webinar. But first, we wanted to set the stage by reviewing the rationale and earlier phases of our measurement development research. As you know, children and youth who are unable to speak or whose speech is unintelligible use AAC systems to support their communication needs. And research shows that AAC can have positive effects on the communication competence, language, and literacy skills for children and youth. Although we assume that this will lead to positive outcomes in social participation, inclusion, as well as well-being, research that demonstrates this effectiveness of AAC and these other important domains is less evolved. So a need exists for practical ways to measure and assess outcomes in home, school, and community settings. At school, teachers, educational assistants, and special educators are well positioned to report on the everyday functioning of students who use AAC as their key communication partners. Learning from educators about the everyday functioning of students with complex communication needs can provide communication teams with important information to assess whether the client's needs are being met, to help predict continued use of AAC systems, as well as provide evidence that AAC interventions are beneficial. Since outcome measures that are specifically targeted to detect the effects of AAC interventions are underdeveloped, our team conducted a multi-phase research study to develop a reliable way for educators to report on the everyday functioning of their students who use AAC and are 3 to 18 years old. Our team initiated a research study to develop a new educator-report measure we called the Functional Impact of AAC, Educator version, or the FIAAC-E for short. The first 3 phases of this earlier research study helped our team to identify measurement domains of interest and develop a scoring strategy. Before sharing the findings of Phase 4 of our research project, we wanted to briefly review these earlier development phases as an orientation to the measurement content and format. Initially, we wanted to identify possible domains to include in our new FIAAC-E measure. We thought that the contemporary research would be an important information source about possible domains to consider for AAC outcomes, as well as environmental factors that could influence these outcomes in school settings. As a starting point, we conducted a systematic review of original peer-reviewed AAC research studies to identify possible functional and environmental domains for the FIAAC-E questionnaire. Through this systematic review of the literature, we created an inventory of 22 functional domains and environmental factors that could be important to consider for an evaluation of effectiveness of AAC interventions in school activity settings. Domains included communication performance, including effectiveness, spontaneity, versatility, social interaction, the quantity and quality of peer interactions, as well as peer behaviors, social validity, that's the acceptance and perceived benefit of AAC, and relevant elements of the school environment like the classroom setting, school relationships, and policy. We developed the definitions for each domain based on the content covered in the source articles, and this was the preparation for the next phase of the study. While all 22 domains could be relevant to the measurement of AAC outcomes for students in schools, we wanted to improve the utility of the tool by keeping only the most important domains for the new measure. To select these domains, we engaged content experts in Phase 2. The experts included 5 of each of the following stakeholders: teachers, educational assistants, speech-language pathologists, occupational therapists, and young adults who used AAC. Educators and clinicians each had more than 5 years' experience supporting students who used AAC, and the young adults had experience communicating using AAC in school. Experts rated the relevance of each of the 22 domains and were offered an opportunity to identify other domains that were not listed. These experts selected half of the theoretical domains as most important to include in the new FIAAC-E measure. 6 domains that are related to communicative functioning showed unshaded, and 5 that were related to contextual factors that could have influenced AAC outcomes. Those are showed as shaded. We needed a way to quantify the domains picked by the content experts in Phase 2 so we could learn more about the levels of functional performance and environmental factors that may affect everyday functioning of students who use AAC. So in Phase 3, we generated statements or items that we believed would tap into each of these 11 domains. On this slide is an example of one of the functional domains. We defined communication effectiveness as the degree to which the student is successful in all forms of written and verbal communication. In this domain, we created a pool of items that included statements such as, my student responds well to my questions. You can see some of the others. We also created item pools for each of the other 10 domains. So as a team, we generated an initial item pool of 235 items and selected 10 to 12 items for each domain to create a draft questionnaire that contained 113 items. Next, we recruited 8 educators with experience supporting students who used AAC from different school boards in Toronto to help us assess the clarity and relevance of the 113 items. This was a 2-part process. First, the educators evaluated the items on their own, and then they met as a group to review and reword or delete items that were unclear or not relevant. This resulted in either the revision or deletion of 38 items on the measure. The outcome of the initial FIAAC-E questionnaire that was then 104 items long. This screenshot shows the first page of the first version of the FIAAC-E. Educators read each item and indicate the degree to which they disagree or agree with the item using a 7-point rating scale. We get a score for each domain by calculating the mean ratings of the items, and the total score of the FIAAC-E is derived from the sum of the domain scores. Higher scores on the domains, and the total score then would suggest higher levels of communication-related functioning or environmental support. Based on our experience with the administration of measures that use this similar format, we expect this version would take about 20 minutes to complete. Anne-Marie will now introduce our latest Phase 4 research, where the FIAAC-E questionnaire underwent revision and testing to confirm its reliability and validity.
Hi everyone, my name is Anne-Marie Renzoni, and I am an occupational therapist in the Communication and Writing Aids Service and work with Tracy as an education coordinator in the centralized equipment pool at Holland Bloorview. Tracy reviewed the first 3 phases of the research that provided support for the content and face validity of the FIAAC-E questionnaire. Steve and I will now spend the rest of the webinar speaking about our recently completed research study. The aim of this study was to reduce further the length of the first version of the FIAAC-E to improve its utility and confirm its reliability and validity. The research design was a 2-part online survey of educators. Eligible educators were classroom teachers, educational assistants, paraprofessionals, and special education staff who had experience supporting at least one student who was aged 3 to 18 years and used aided AAC, such as a communication book or speech generating device, to support communication at school within the last 2 years. Educators who were interested in participating in the study accessed the online survey using a common web link. The survey consisted of 3 parts: a demographic page that asked for basic background information about the educator, a profile page that asked participants for information about one student they supported who used AAC at school. This student served as the basis for responses on the FIAAC-E questionnaire and the 104-item version of the FIAAC-E. At the end of the survey, educators who completed the questionnaire optionally indicated their interest in doing the FIAAC-E a second time so we could study its test-retest reliability. Interested educators were invited to return to redo the FIAAC-E 2 weeks later. We used a variety of notification strategies to inform eligible educators about the opportunity to participate in the survey. Educators learned about the AAC survey through their principals or communication teams at 6 different school boards in Ontario, Canada, through teachers' special educator associations and special interest online community forums, including the Council for Exceptional Children and Quality Indicators for Assistive Technology, from members of our team that attended special education and AAC-related conferences, including the Council for Exceptional Children and the Assistive Technology Industry Association, and also through invitations posted on our hospital social media platforms and notifications sent to members of other AAC and clinical associations and special interest groups. We had 61 educators complete the first survey and 19 returned to do the FIAAC-E again. The red dots on the map of North America show the province or state where survey respondents worked. The size of the dots reflects the relative proportion of educators who responded from 13 different provinces and states. About 70% of respondents worked in the province of Ontario, Canada. This was not surprising as our home province was the primary focus for our recruitment activities. 50% of the educators were teachers, 30% were special educators, and the rest were educational assistants or paraprofessionals who had experience supporting at least one student with AAC needs in the past 2 years. This slide shows the number of students that educators supported during their careers. Roughly half of the educators who responded had experience supporting fewer than 5 students who used AAC. This figure shows the number of educators who had experience supporting students who used AAC by age grouping. Roughly half of the educators had experience supporting preschoolers and school-age students who used AAC, whereas fewer than 20% had experience supporting older adolescents and young adults. We asked educators who responded to tell us a bit about one student who used AAC that they either support or had recently supported in the classroom. 3/4 of the students were male and ranged in age from 3 to 17 years. The mean age of students reported was 9 years old. We asked how the students selected usually use their AAC to communicate with school staff and peers. The plot shows the 6 most common modes of communication with non-aided forms, such as gestures and sounds, being used by nearly all students. 3/4 of the students use either or both low-tech communication, such as symbols, communication boards, or books, and high-tech AAC, such as speech-generating devices. Far fewer use sign language or single messages for communication at school. Educators reported that their students use these forms of communication more with school staff than with their peers. Steve will now speak about the methods used to reduce the length of the questionnaire and estimate the measurement properties of the FIAAC-E questionnaire.
My name is Steve Ryan and I'm a scientist in the Blue Review Research Institute at Holland Blue Review in Toronto. To meet our objective for reducing the length of the FIAAC-E, we used survey ratings to run statistical analyses to flag items that adversely affected the estimation of domain scores. We eliminated 15 items based on their weaker associations with other items within the same domain. We repeated these analyses to flag additional items, and our team reviewed and eliminated 12 of the flagged items by consensus. The revised questionnaire was 77 items long, making it about 3/4 of the length of the original version. Another research objective was to confirm the reliability of the new version of the FIAAC-E. In this study, we evaluated reliability in 2 ways. First, we considered how well the items within each domain related to one another. We used a statistic called Cronbach's alpha to measure this property. This graph shows the alpha levels we calculated for each domain. By rule of thumb, the alpha statistic should be greater than 0.7. Our data showed that the internal consistency of all 11 domains and the total scale exceeded this threshold for acceptability. The second type of reliability we considered was test-retest reliability. This allowed us to assess the repeatability of the measure from one time to another. As mentioned, 19 of the 61 educators who completed the FIAAC-E once returned to do it a second time. The data collected from these 19 educators allowed us to calculate an agreement statistic called ICC, or Interclass Correlation Coefficient. This graph shows the estimated ICC for each domain. The rule of thumb is for each ICC to be greater than 0.7. We learned that all ICCs were above the 0.7 threshold, indicating that levels of repeatability of the shorter questionnaire were very good. In the initial survey, we asked educators to provide a global rating of their students' level of everyday functioning for face-to-face communication. This graph shows the numbers of students who were assigned ratings of 1 are the lowest level of functioning, to 10, or the highest level of functioning for face-to-face communication. The mean rating was just under 5, with a range of scores from 1 to 9. We asked this global rating question because we wanted to check its relationship with the levels of functioning and environmental supportiveness estimated by the FIAAC-E through its domains. As expected, we found that the domains measuring functioning, shown here unshaded on the left, correlated well with the global ratings of everyday functioning for face-to-face communication, whereas the domains measuring levels of environmental supportiveness, shown shaded on the right, did not relate well with the global ratings. These ratings were expected and provided evidence to support the validity of the FIAAC-E. Now that we have emerging confidence in the measurement properties of the questionnaire, we can begin to use it in research to explore relationships among its different domains. While these findings may be viewed as exploratory, we discovered very high correlations among 4 functional domains of communication function, effectiveness, spontaneity, and expressive language performance. Interestingly, we found that higher levels of school supportiveness measured by the FIAAC-E were also associated with higher levels of functioning in these same 4 domains. This means that students who were reported to have higher levels of communicative functioning tended to be in more supportive school environments, and the reverse was true. Similarly, we found higher levels in these 4 domains, and school supportiveness were also associated with higher levels of receptive language performance, benefits of the AAC system used by the student as indicated by social validity, and the nature of interactions with peers and others at school. We also learned that the school environments that were highly supportive were also linked to higher quality collaborations between educators and communication team members and parents. However, the quality of these collaborations was not associated with other domains. Further investigations using different methodologies are needed to confirm, explore, and explain more about how one domain influences another. In summary, we analyzed the survey responses from 61 educators to inform decisions about items to eliminate, and this process yielded a scale with 27 fewer items. We were able to show that the reliability of the domains and total scale were acceptable for the updated version of the FIAAC-E. We also provided additional support for its validity by showing strong associations between global rating of everyday communication and relevant domains. Together, these results provided early evidence that the FIAAC-E is a reliable educator-report measure of the communicative functioning of students with AAC needs. We will be making the questionnaire freely available for use by the AAC community and provide information on how to access the questionnaire to those who are interested. Outcomes of future AAC research studies will help to improve the utility of the questionnaire and re-estimate its measurement properties. Other studies will need to be done to test the ability of the FIAAC-E to detect important change in functioning and environmental supportiveness following the introduction of an AAC intervention. The research presented in today's webinar is part of the measurement development work we are doing to understand better the real-world effectiveness of AAC for children and youth with complex communication needs. The AAC Outcomes for Kids Research Alliance is a virtual community of clinicians and researchers based at AAC clinics across Canada who have a common interest in improving outcomes for children and youth who use AAC. Our goal is to create an inventory and promote the use of reliable, well-targeted measures for AAC research, clinical, and education-related applications. We're creating new AAC measures that collect the perspectives of different communication partners as well as young people who use AAC. For example, we developed a companion parent report measure called a Family Impact of Assistive Technology Scale for AAC to evaluate outcomes that affect children and youth and their families. This parent report questionnaire and its administration manual are freely available on a web-based innovation platform at flintbox.com. We plan to make other measures available using this same platform. We wish to thank educators who participated in the study. Their involvement helped to advance the development of a new measure that we hope will lead to new understandings and ways to improve the everyday lives of students who use AAC. We would also like to thank the school boards, communication teams, and special interest groups that notified educators about the research survey. We gratefully acknowledge funding support for this project from the Holland-Bloorview Kids Rehabilitation Hospital Foundation through the Center for Leadership in Participation and Inclusion. Please contact us if you have any questions or would like further information. Thanks to everyone who participated in today's webinar.